Hi, this is Dr. David Branham. Today I'm doing a short video on hypothesis testing. This is the material you'll find in chapter 11 of your readings, of your assigned readings. I want to remind you that if you see any contradiction between what you read in chapter 11 and this video, on the test, be sure to go with what you read in chapter 11. That's the actual assigned reading. This video is just supplementary. The hopes here are that this video will help you understand better. And I don't think there will be any contradictions between the reading and the video, but just in case, I want to make sure that you know that. Okay, I have a PowerPoint presentation for you today. And so I'm going to put that PowerPoint presentation into my share screen here and share it with you and let you know that these are my thoughts on chapter 11. To begin with, there we go. Start with testing hypotheses. That's what this chapter is about, is testing hypotheses. And we'll start with what we do as researchers, as social scientists, nonprofit managers, as people in public administration. Anytime we have data and we want to have a hypothesis to test to see if that hypothesis is true, we can use our data to do it. And this is basically what we're doing here in this class, is we are testing hypotheses and we are seeing if the data that we have supports those hypotheses, and it will better help us go forward with our research and help us go forward with our conclusions. Okay, start out with a couple of definitions. One, an alternative hypothesis. That's a declaration by a researcher that one group is different from another, and it's usually due to some variable. Okay, so an example is that UHD students have higher IQs than Harvard students. That would be an alternative hypothesis. I can actually see some support for that because it really kind of depends on what kind of IQ you're measuring, because in a lot of cases, the UHD students are clearly smarter about their day-to-day life than Harvard students. So I can see where data would actually test this alternative hypothesis and it would come true. So that's an alternative hypothesis. These hypotheses are statistically tested to see if there's evidence that they are true. And then we report that evidence, okay? Now, we don't prove that our alternative hypothesis is true with statistics. You can't prove anything with statistics, but you can use that data to support your conclusions, okay? In opposition to an alternative hypothesis, the null hypothesis or a null hypothesis is a declaration that there's no effect. And it's the alternative, and it basically says that the alternative hypothesis is not true. So an example of a null hypothesis in comparison to our original example of an alternative hypothesis is that UHD students have the same IQs as Harvard students. Basically, it's saying the null hypothesis says there's no effect, that the alternative hypothesis, the effect that you thought was there, is not there, okay? So we have two examples on this page. Alternative hypothesis, that's the researcher hypothesis. UHD students have higher IQs than Harvard students. The null hypothesis, which basically says there's no effect, is that UHD students have the same IQ as Harvard students. Remember, the null hypothesis isn't the opposite of the alternative hypothesis, in that we would say UHD students have lower IQs than the Harvard students. Null hypothesis is basically a hypothesis that says there's no effect, okay? So the null hypothesis properly pronounced in this would be that there is no difference between IQs of UHD students and Harvard students. Now, a few things about the null hypothesis. First, you should always remember, let me reiterate again, the null hypothesis says there's no effect, that your variables, if your independent variables are hypothesized to have an impact on dependent variable, your null hypothesis will say those independent variables have no impact on the dependent variable, okay? If the alternative hypothesis, which is your hypothesis, is that there's a difference due to an independent variable, then the null hypothesis is that there is no effect, okay? So example here, alternative hypothesis, group one, will score higher than group 2. Okay, null hypothesis would be group 1 is equal to group 2 in the scores. All right, and I said that several times. I just need for you on your tests to make sure you understand that. Okay, to test a hypothesis, the researcher compares the means of each group and then performs a t-test to see if the difference between those two means is statistically significant. So in the example in the previous page, we would take the mean IQ of the UHD students and the mean IQ of the Harvard students, see if there's a difference in means, and then if there is, we test to see if that difference is statistically significant. Okay, the null hypothesis is actually the tested hypothesis when we do this. So our results will be either one of two things. One, to reject the null hypothesis and say the evidence goes with our alternative hypothesis, or we fail to reject the null hypothesis and the evidence does not support the contention that our alternative hypothesis is true. Okay, so it's important that you understand there's only two results. One, either you reject the null hypothesis or you fail to reject the null hypothesis. When you reject the null hypothesis, you say the evidence is that the alternative hypothesis is true. When you fail to reject the null hypothesis, you're saying the evidence does not support the alternative hypothesis, that it's true. Okay? Now, the t-score, remember we said the t-score is what we use to determine if those difference of means, if the null hypothesis can be rejected or not, okay? So in social sciences, it's traditional that the critical value be rejected. To reject the null hypothesis is at the 0.05 level, okay? That's in social sciences. That includes nonprofit management, public administration, government, sociology, all social sciences. The normal critical value is 0.05. Now, there are some journals and some publications that make the critical value different. Could be 0.1, depending on your data. That's a very low standard in most cases, but sometimes it's justifiable when you only have a very small sample. More often than going to 0.1 is the 0.01 level, where it's a very, very high standard to reject the null hypothesis. That's not normal in social sciences because we don't want to throw out data that truly does support the alternative hypothesis at a high level, at the 0.05 level, but it may be more prevalent in things like medical care. For instance, drug tests. They may want it at the 0.01 level because the consequences are so high. But in social sciences, it's typically the 0.05 level. Now, two-tailed tests are used when the alternative hypothesis is not directional. Okay, in these hypotheses, the alternative hypothesis is that there is an effect, but the direction of that effect is not known. Okay, for an example, there may be a hypothesis that says the IQ of UHD students is different than the IQ of Harvard students. In such an alternative hypothesis, as it's declared, we don't know the direction of the difference. We don't know if UHD students would be higher or lower in this stated alternative hypothesis. Here, the alternative hypothesis, the hypothesis does not declare if the IQs are higher or lower. Okay, so in these two-tailed tests, with large samples, if you have a sample over 200, for instance, to achieve critical value at the 0.05 level, the t-score either has to be above 1.96 or below negative 1.96. That would mean that any t-score between negative 1.96 and 1.96, for instance, a negative 1 or a positive 1, both of those are between negative 1.96 and 1.96. In each of those cases, we would have failed to reject the null hypothesis, and the evidence would not be strong enough to support our alternative hypothesis. However, if we get a t-score higher than 1.96, say 2.35, or lower than negative 1.96, negative 2.35, for instance, then we will have the evidence to reject the null hypothesis and say that our alternative hypothesis is supported by the evidence. Remember, it's not proven, but the evidence does support it, okay? So in two-tailed tests with large samples over 200, You have to get it between either below, excuse me, you have to get your t-score below negative 1.96 or above 1.96 in order to reject the null hypothesis. If you do not get that t-score in that range, then you fail to reject the null hypothesis. This is a pretty high standard for, for rejecting the null hypothesis. Now, in situations where you have a one-tail test, and these are more often in social sciences, in all honesty, one-tail tests are used when an alternative hypothesis is directional. In these hypotheses, the alternative hypothesis is that there's an effect and the direction of that effect is known. Okay, for example, an alternative hypothesis that says the IQ of UHD students is higher than the IQ of Harvard students. That's directional. We say the IQ is higher, okay? Here, the alternative hypothesis does not declare if does declare if IQs are higher or lower. It declares a higher IQ, okay? So we have a direction. So in this situation now we have a one-tail test. In a one-tail test with large samples over 200, to achieve a critical value of at the 0.05 level, your t-score simply needs to be above 1.65, okay? It doesn't need to be below anything. Anything below 1.65, no matter how low it is, fails to reject the null hypothesis. But if you get your t-score that you get in your statistical analysis is above 1.65, you can say we're going to reject the null hypothesis and our alternative hypothesis is supported by the evidence, okay? If your hypothesized difference is in the correct direction and you get a t-score above 1.65, for example, 1.79, you reject the null hypothesis and declare that the data provides evidence that your hypothesis, your alternative hypothesis, is true. If you don't get that t-score above 1.65, say 1.04, you fail to reject the null hypothesis and your evidence does not support your conclusion, the conclusion of your alternative hypothesis, okay? It's important that you use the correct terminology in stating your results. You either fail to reject the null hypothesis or you reject the null hypothesis. Don't say the alternative hypothesis is true. That is not the correct terminology. You can say the evidence supports the alternative hypothesis, but don't say it's true. You haven't proven that it's true. So you have two results, either fail to reject the null hypothesis or reject the null hypothesis. It's important. This is important because the null hypothesis is what's actually reported. And it's the hypothesis. This is actually tested with your statistical analysis. Now, remember the t-test is only used to see if there's a difference between your means. If that difference between your means is large enough to determine that there really is a difference and the evidence supports that. It doesn't tell you how big the difference is. You can't say, oh, I got a really big t-score, a 10.5. So the difference is really large. No, that's not what the t-score is for. Okay, the t-score is only determined if there is a difference or if they're not. Remember, there's only two results. Fail to reject the null hypothesis or reject the null hypothesis. That's what the t-score determines. It doesn't determine how much you did it by. It's only a test to see if you've achieved statistical significance. Okay, errors. We talked a little bit about errors earlier in the video, but I want to go over the errors because it's important that you know this, especially for your tests, okay? Errors can happen in hypothesis testing. Remember that it's always possible that you got a sample that is statistically different than its population. It's always possible, okay? When you have a large sample, that's really rare to do that. It's hard to pick out, for instance, 200 people who are completely different than the population if you're doing random sampling, okay, where everyone has an equal chance of being selected. But it can happen. It's always a possibility. I mean, it's just like winning the lottery. It's always a possibility. It almost never will happen, but it can happen, okay? So there are two types of errors, type 1 error and type 2 error. So first, type 1 error. Type 1 error occurs when a t-test results in the rejection of a true null hypothesis. In other words, you find statistical significance when you shouldn't have found it. Okay, it's a rare occurrence, but it does happen about 5% of the time because that is our criteria, the 0.05 level. Okay, now if you want to move your level to 0.01, that's a very high standard. Only 1% of the time will you make a type 1 error in that situation. So at the 0.05 level, you can make it about 5% of the time. Okay, that's a high standard. 95% of the time, if you can reject the null hypothesis, that means the alternative hypothesis is true about 95% of the time. 5% of the time, no. So remember that that standard's there. We always have the possibility of error in statistical analysis, but the possibility of type 1 error is pretty rare. Okay, if a null hypothesis is false, you can't have a type 1 error. By definition, you can't have one. So just remember that. Type 1 error occurs when you reject the null hypothesis, when you should not have rejected the null hypothesis, when the null hypothesis is actually true and there's no effect, okay? And that happens very rarely. Now, type 2 errors, on the other hand, a type 2 error occurs when a test fails to reject the null hypothesis when it should have done so, okay? This means that the alternative hypothesis was true, but the statistical analysis did not provide adequate evidence of the truth. This happens far more often than type 1 error. In a lot of cases, your alternative hypothesis will actually be true, but you won't find enough evidence to support that conclusion. Okay, that happens a lot because, in all honesty, we have a very high standard when it comes to statistical evidence. 0.05 is a high standard. So type 2 error occurs quite often. So when you fail to reject the null hypothesis, that doesn't mean you just throw it away and say, okay, I had an alternative hypothesis, wasn't true, let's go on. There's a good chance it was true. So don't worry about that. It doesn't matter if it's true. Failing to reject the null hypothesis is not proof that the alternative hypothesis is untrue. Therefore, go on and try again and go on with your, okay? I'm very hopeful that this helps you with chapter 11. I think this video will help you a lot with the questions and your understanding of the material. It also will help you if you want to stop it, start it, read your PowerPoints, and take notes. You can do that as well. So thank you so much for the video. I appreciate the time, and I hope this helps you out.